Okay, this is a simple mutual inductance problem. And what it's saying here is it says, consider the circuit shown below if I1 of t is 400 cosine 120 pi t amps and the maximum value of V2 of t is 100 volts. What is the value of the mutual inductance linking L1 and L2? Okay, this one actually doesn't give the dot of either inductor, and it doesn't really need to because it has the question just asking what's the maximum value. So one thing that we can see here is if we just sort of thought that the dot convention was plus on the top, which that would be sort of standard convention, then and we have V2 labeled up at the top like that, and we could say, okay, well, we think V1 is this way. And we're, typically if the dots were at the top, we'd want to label the currents going into the dot, so I2 and I1. So one of the things that I guess we should say is, okay, well, first off, and this is why the dots are not important, is what is I2? Well, I2, for sure we know I2 is 0, right? It's sitting there with an open on that second, or this side over here, there's this open circuit, so we know there's no way for any current to flow. And so, we know that we should be able to write V2, the phasor, should be equal to j omega L2 times I2 plus, well, maybe I shouldn't say plus, a portion either plus or minus depending on the way we have it. And we know, okay, the way we define it there, we know that the sign convention is satisfied with V2 and I2 on that inductor, so this one should definitely be plus. But then we don't know, this should be j omega m I1, and we don't know whether or not this should be a plus or minus sign because it does depend on the dot convention. But notice, since I2 here is 0, then this term goes away, and so we just get V2 as j omega m I1, and whatever the proper sign should be with regard to the dot convention doesn't really matter because they tell us that there's a maximum value of V2, the maximum value of V2 of t is 100 volts, so the maximum value of the V2 phasor is 100, and so V2 is equal to j omega m I1. So the magnitude of V2 is equal to the magnitude of the other side. So that's magnitude of omega m I1 is omega m magnitude of I1, since the magnitude of j is that. And so we've got 100 over omega 400 is equal to M, the mutual inductance. So what is omega? Omega is 120 pi. So we get 1/4 120 pi is equal to M, and so M turns out to be 6.63 times 10 to the minus 4 henries, which that would be 663 times 10 to the minus 6 henries, which is equal to 663 microhenries. Notice that, and I didn't use enough significant digits to completely compare to the answer, but you can see that the mutual inductance is 663.1 microhenries, so that's exactly as we would expect. So there's a real simple mutual inductance problem that hopefully will make sense to you. You could actually define dots and do everything that way, but it's sort of better to not actually do that since they don't give it to you in this case, and just assume that you're going to get the maximum like we did. So okay, that's the simple problem, and we'll turn that over.